Welcome to Brain Vision.
So first thing we want to do is parametrize the part of the sphere that lies within the paraboloid. So what we'll have is that the equation of the sphere is x squared plus y squared, and then instead of plus z squared, it'll be plus z minus 2 squared equals 2 squared. So this can be rewritten, and now what we have is the absolute value of z minus 2 is equal to the square root of 4 minus x squared plus y squared. And the reason we want to write that is so we can get it into cylindrical coordinates, which would be the absolute value of z minus 2 equals the square root of 4 minus r squared. Then what we can do is, it might help us to picture what we're looking at. So if this is our paraboloid right here, then what we have is a sphere that's kind of like this, and this is our sphere right here, and this is the paraboloid, so it's kind of encompassing it around. And we need to know what the z coordinate of the points are on the circle. So what we'll have is this equation of the sphere, x squared plus y squared plus z squared equals 4z. And then our equation of the paraboloid is x squared plus y squared equals z. So with this, we just subtract the equation of the paraboloid from the equation of the sphere, and we see that z squared equals 3z, which ultimately tells us that z equals 0 and z equals 3. So what we know is that z will be between 0 and 3. And then with regards to the part of the sphere that lies above the paraboloid, this is going to be similar to before. Z equals 2 plus the 4 minus r squared, so we just added the 2 to the other side. So now when we parametrize this, what we're going to get is r cosine theta, r sine theta, 2 plus the square root of 4 minus r squared. And that is where r is between 0 and the square root of 3, because we know z is between 3 and 4. So now to find the surface area, we're going to use the following formula. A of s is equal to the double integral over the region D of r cross r theta dr d theta. So now that we're doing this, we know that this right here, if we just turn this into our vector, we can find r to be equal to cosine theta sine theta negative r over the square root of 4 minus r squared. Then with regards to r sub theta, or the partial derivative of r with respect to theta, it's going to be negative r sine theta, r cosine theta, 0. And then when we cross these, so crossing these, we end up getting r squared cosine theta over the square root of 4 minus r squared, r squared sine theta over the square root of 4 minus r squared, r. And then what we'll do next is we will take the magnitude of that. So when we take the magnitude, this will actually end up simplifying a little nicer for us, and we end up getting 2r over the square root of 4 minus r squared. Now we can take the integral of this. We know our bounds to be 0 to 2 pi and 0 to root 3. So we'll have 2 over r over the square root of 4 minus r squared d theta dr. Now notice there are no theta values, so we can immediately move this theta over here evaluate this integral, so we'll just get 2 pi of the times the integral that were given originally. With that in mind, we just evaluate the integral, and it comes out nicely for us. What we end up getting is 2 pi times a negative 2 plus 4. So that's going to equal 2 pi times 2, which gives us 4 pi.